Okay, let's do some homework solving absolute value equations and inequalities. All right, so just key thing to remember that the absolute value must be isolated. That's the idea. It's got to be isolated. So if it's isolated, we're in business. So here, number one, it is isolated. It's by itself. And this is positive. So when it's positive, we can split it into two, right? Drop the absolute value. K plus 8 is equal to 2. And then K plus 8 is equal to negative 2. And we solve both of these for K. So left-hand side, I'm going to subtract 8 from both sides. So K is equal to negative 6. Right-hand side, I'm going to subtract 8. K is equal to negative 2 minus negative 8. They're both negative, so we're adding them. So negative 10. So K in both scenarios, in either scenario, is negative 6 and negative 10. We'll only do this once, but if we plug it back in, if we plug negative 6 back in, right, this would be negative 6 plus 8 is 2. Absolute value of 2 is 2. If we plug in negative 10 plus 8 is negative 2. Absolute value of negative 2 is 2. So if you're ever unsure, just plug it back in. That'll be the only time I do that. Okay. We have absolute value is equal to 0. Now, 0 is not negative or positive, or it's not positive. So we just solve the 1, right? We're just going to rewrite it one time and figure out when is this true. So I'm going to add 3. So 4x is equal to 3. Divide both sides by 4, and x is equal to 3/4. Positive 3/4. All right. Yeah. When it's equal to 0, it's just the 1. Okay. Number 3. 8 plus absolute value of 4x is equal to 24. So we got to isolate the absolute value. So we're going to take away the 8. So absolute value of 4x is equal to 16. 24 minus 8. Okay, it's isolated, the absolute value that is. So we're going to split it into the two variances. So negative 16 and positive 16. Okay, solving for x on the left. X is equal, 16 divided by 4 is 4. On the right, divide both sides by 4. Negative 16 divided by 4 is negative 4. So in this case, x is either 4 or negative 4. Okay, number 4. I'm going to add 2 to both sides, right? Because we're trying to isolate the absolute value. So absolute value of 6 plus 2x is equal to 2 plus 2, 4. The absolute value is isolated and 4 is positive. So we can split this into the two equations. 6 plus 2x is equal to positive 4. 6 plus 2x is equal to negative 4. Okay. The right-hand side, we're going to subtract 6. So 2x is equal to negative 2. Dividing both sides by 2, we see that x is equal to negative 1. Right-hand side, subtracting 6 from both sides, right, because we want to isolate x. 2x is equal to, they're both negative, right, negative 4 minus 6, they're both negative, so you add in this case 10. But the negative sign remains. Divide both sides by 2, and x is equal to negative 5. Number 5. We want to isolate the absolute value, so I'm going to subtract 1 from both sides. The absolute value of 7x is equal to 22 minus 1, 21. Okay, it's isolated, 21 is positive, so we're going to split it into 2. 7x is equal to 21. 7x is equal to negative 21. Okay, on the left, dividing both sides by 7, x is equal to 3. On the right, dividing both sides by 7, x is equal to negative 3. Okay, number 6. Negative 5, absolute value of 3x plus 2 equals negative 15. So this is negative 5 times the absolute value. So we're going to divide both sides by negative 5. Cancels on the left. So 3x, absolute value of 3x plus 2 is equal to negative 15 divided by negative 5, positive 3. Absolute value is isolated. The answer is positive. So we can split this into the two variances. So this is 3x plus 2 is equal to 3. And then 3x plus 2 is equal to negative 3. All right, on the left, minus 2 from both sides. 3x is equal to 3 minus 2, which is 1. Dividing both sides by 3, x is equal to 1/3. On the right, subtracting 2 from both sides, 3x is equal to, so negative 3 minus 2. They're both negative, so we're adding negative 5. Dividing both sides by 3, x is equal to negative 5/3. That was the front. So hopefully you can follow along. All right, now we're doing inequalities. So the first side was equations. Now we're doing inequalities. With the inequalities, there's a couple different moving parts here. So we still got to isolate the absolute value. However, when we are splitting it in two, so to speak, as long as the solution side is positive, right? We can split it into 2. And however, for the negative part, we have to flip the sign. So we're going to flip the sign for the negative part. Okay, so subtracting 5 to isolate, we get absolute value of negative 2x is less than or equal 6 minus 5, which is 1. Okay, it's positive, so we're going to split it into 2. This is going to be negative 2x less than or equal to 1, and negative 2x greater than or equal to negative 1. So our little note here is for this, what's happening right now. Right, we have to flip the sign always. That's part of the process, and then make the answer negative. Okay, solving on the left, dividing by negative 2. So when you divide by a negative, you have to flip the sign. So there's going to be a lot of sign flipping. Flip the sign. when you divide or multiply by a negative. So x is equal, or not equal, x is going to be greater than or equal to negative 2. Negative 1/2, sorry, negative 1/2. Okay. On the right-hand side, we're dividing by negative 2, both sides. So again, when you're dividing by a negative, you got to flip the sign. So this is going to be x less than or equal, negative divided by negative is a positive 1/2. Okay, so these are our two inequalities. When you find the two, immediately tick out the graph, right? 2 tick marks to represent each number, write them in numerical order. Smallest on the left, so negative 1/2, positive 1/2. Okay, it's going to have a closed circle because it's or equals. So x is greater than negative 1/2. So greater than negative 1/2 will be to the right. X is less than 1/2. So x is less than 1/2 will be to the left. And then they meet in the middle. So the interval notation for this is going to be, so negative 1/2, you just grab the numbers, right? Just grab the numbers. And because it's closed circles, it's brackets. There's the interval. There's the graph, the interval, and the inequality. Technically, the inequality would be one piece, but I'm not too worried about that. What I'm saying is the inequality would look like this. Negative 1/2 x 1/2. It's like, well, how do I know that that's what it is? Well, it's because when you graph it, the graph goes towards each other, like towards the points. That's how you know it's one piece. Otherwise, it would be two separate pieces. You can leave it as two separate pieces. There's nothing wrong with that, but just the technicality of it all. All right, number 8. It's isolated. It's isolated. Okay, so we have, it's positive, so we're going to split this into 2. So this is going to be 2/3 x plus 6 is greater than or equal to 10. 2/3 x plus 6 less than, right, because we have to flip the sign, part of the process, less than or equal to negative 10. Right, we have to flip the sign on the negative one. And we just solve each of these. So minus 6, 2/3 x greater than or equal, 10 minus 6 is 4. All right, whenever we want to get rid of a fraction that's being multiplied to an variable, we use the reciprocal. Both sides. Now, if you were to multiply or use a negative here, you would definitely have to flip the side. It's not negative, it's positive. So we don't need to flip anything. So on the left, those cancel, leaving behind x greater than or equal. Now, when you're multiplying a whole number by a fraction, it's the whole number times the top of the fraction. So 4 times 3, which is 12. 12 over 2. 2 is just along for the ride. This is going to be 12 divided by 2 is 6. So x greater than or equal to 6. On the left, or on the right, we're going to subtract 6 from both sides. So 2/3 x is less than or equal. So negative 10 minus 6. They're both negative, so we're going to add 16. And then the negative stays. To get x by itself, we're going to multiply by the reciprocal. on the left cancels. That's what we wanted to happen. So x is less than or equal to negative 16 times 3/2. So again, you multiply the top, the number times the numerator. So 16 times 3, 16, 32, 48. So negative 48 over 2. That'll reduce to negative 24, by the way. So x, in conclusion, x is less than or equal to negative 24. All right, to graph this guy, we're going to make our 2 tick marks. It doesn't have to be, right. It doesn't have to be precise. This is accurate. So I'm going to write them in numerical order. Negative numbers are always to the left. Smaller numbers are to the left. 6 is going to be to the right. Okay, so looking at the first inequality, x is greater than or equal to 6. So it's going to be a closed circle because it's or equals, and it's greater than, so it's to the right. Okay, x is less than negative 24. So again, closed circle because it's or equals. And then we shade less than, so smaller than to the left. All right, understand that to the left is negative infinity. To the right is positive infinity. All right, for the interval notation, you literally just grab all the numerical components in order. So what do I mean by numerical components? Negative infinity, from left to right, negative infinity, negative 24, 6, infinity, right? They're all in numerical, not numerical, but the order in which they appear, right? The order in which they appear. Parentheses always gets put on the infinity symbol, both infinities, negative and positive. And then negative 24 and 6 will get brackets because it's a closed circle. And then because we have 2 separate pieces, we union them together. Might have to watch that a couple times so you can get some practice on that. Or watch this one. Number 9. We have absolute value of 5 plus 2x plus 1 is greater than or equal to 10. First thing I'm going to do is isolate the absolute value. So I'm subtracting 1 from both sides. This is going to be the absolute value of 5 plus 2x greater than or equal to 9. All right, it's isolated, it's positive, so we can split this into 2. 5 plus 2x greater than or equal to 9. 5 plus 2x less than, right, because we always flip the sign, that's part of the process, and make it negative. Negative 9. All right, solving on the left, we have minus 5 to both sides. So 2x greater than or equal, 9 minus 5 is 4. Divide both sides by 2. X greater than or equal, 4 divided by 2 is 2. So that's 1 inequality. Second is going to be, again, minus 5, 2x less than or equal. All right, negative 9 minus 5. They're both negative, so we're naturally going to add them. 9, 10, 11, 12, 13, 14. And keep the negative sign. Divide both sides by 2 to isolate x. And we see that x is going to be less than or equal to negative 14 divided by 2, which is negative 7. All right, to graph this, we put our tick marks, right? We have 2 values, so we put 2 tick marks. In numerical order, negative 7 will be to the left because it's smaller than 2, and 2 will be to the right because it's larger than negative 7. The circles, they will get closed circles because it's or equals. Okay, doesn't matter which one we look at first. Let's do x is greater than or equal to negative 2. So x has to be greater than 2. Greater than 2. So greater than is to the right. X is less than or equal to negative 7. So less than is to the left of negative 7. So clearly we have two pieces. Right? Understand negative infinity is to the left. Positive infinity is to the right. So we grab all of our numerical symbols for interval notation. For the left piece, negative infinity and negative 7. For the right piece, 2 and infinity. And negative infinity always gets parentheses. In this particular case, negative 7 is going to get the bracket because we're including it. And for the right piece, 2 will get the bracket because we're including it. And as always, infinity gets the parentheses. Two pieces that we union together. Okay, number 3. Or number 10. This is negative 1/3. Absolute value 3x plus 3 less than negative 3. All right, to isolate the absolute value on the left, we're going to have to multiply this by the reciprocal. So the reciprocal of 1/3 is 3, right? 3 over 1. I don't really care about the over 1 part. But it's also negative. So I'm going to have to multiply by a negative as well, right? Because I want to completely get rid of the things outside the absolute value. So negative times negative is a positive, so it goes away. 3 times 1/3 also goes away. Cancels. What I do to one side, I have to do to both sides. So if I multiply the left by negative 3, I have to multiply the right by negative 3. So we get the absolute value of 3x plus 3. Now, I multiplied by a negative, right? We multiplied by negative 3. So when we multiply by negative 3, we have to flip the sign when you multiply by a negative. This is going to be greater than, right? We multiplied by a negative. Flip the sign. All right, greater than, negative times negative is a positive. 3 times 3 is 9. Okay, it's isolated. 9 is positive. Split it in 2. 3x plus 3 greater than 9. 3x plus 3 less than negative 9. Again, you flip the sign because it's part of the process. So the 2 times we flip the signs. 1, when you multiply or divide by a negative, and then 2, part of the process when you split it in 2. And then any other time after that, if needed. So minus 3 from both sides. We get 3x is greater than 9 minus 3 is 6. Divide both sides by 3. X is greater than 2. On the right, subtracting 3. 3x is less than negative 9 minus 3. They're both negative. So we're adding 9, 10, 11, 12. And we keep the negative. Divide both sides by 3. X is less than negative 4. Okay. Graphing 2 tick marks in numerical order. Negative 4 on the left, 2 on the right. So this is going to be open circles because it's strictly greater than and strictly less than. All right, x has to be greater than 2. So greater than 2 is to the right. X has to be less than negative 4. So we're going to the left. We see that negative infinity is to the left. Positive infinity is to the right. So when we do our interval notation, we grab all of the numerical values, negative infinity, -4, negative infinity gets the parentheses. -4 is going to get parentheses because it's an open circle. 2 to infinity, again, parentheses, open circle. Infinity gets parentheses always. And it's two different pieces. So we are unioning them together with a U. Okay. Almost done. Second to last. Number 11. Okay. This one has everything, right? It has everything. So whenever you have something multiplied and something added or subtracted, it's best to handle this one first. The add or subtraction first. Handle that first. This is going to be first. So the first thing I'm going to do is subtract 3. So we get -2, absolute value, 2x plus 6, less than -2 minus 3. So they're both negative, so we add 5, and then we keep the negative sign. All right, to isolate it even further, we're dividing both sides by -2. Now here, because we're dividing by a negative, we have to flip the sign. Because we're dividing by -2. So we get absolute value, 2x plus 6, greater than 5 over 2. Right, negative divided by negative is a positive. 5 over 2. Okay, it's isolated, and the solution is by itself. It's positive. So we're going to split this in 2. 2x plus 6 greater than 5/2. 2x plus 6 less than -5 over 2. Okay, left-hand side. I'm subtracting 6. Okay, -6. This is where fractions, you got to be nice at fractions. Okay, we're going to need a common denominator. So 2x is greater than. So do we get a common denominator? We can get a common denominator of 2. So this would be 12 over 2. Right, 6 is equivalent to 12 over 2. So 12 over 2. So 5/2. 5 over 2 minus 12 over 2 is -7 over 2. All right, we're going to divide everything by 2. So here, if we divide by 2 like so, there's a couple different ways to think about this, right? I feel most viewers would do what I'm doing right now, dividing both sides by 2. And then right here, you kind of get stuck. So understand that when you're dividing by 2, which is a whole number, all whole numbers are over 1. And then they teach in elementary or middle school, I don't know which one, keep, change, flip. Right? When you're dividing by a fraction, you keep, change, flip. Meaning you keep the top, -7/2. You change division to multiplication, and then you flip the bottom. So 2 over 1 will flip to 1 over 2. So you multiply. So this is going to be x greater than top times top, bottom times bottom. So -7 times 1 is 7. 2 times 2 is 4. All right, I'll show you another way to look at this in the right example. So here we're going to subtract 6 from both sides. So 2x is less than. Okay, so here they're both negative, so we have to add them. So this is going to be, we've already established 6 is 12 over 2. So 12 plus 5. 17 over 2. So negative 17 over 2. All right, so here you're going to divide by 2, right? Naturally, divide by 2, because that's how you get x by itself. Understand that when you're dividing by 2, right, that's the same as multiplying by 1/2. So one could say, I'm going to divide both sides by 1/2, or I'm going to multiply both sides by 1/2. That's equivalent to dividing by 2. And that's exactly what happened on the left eventually, right? You're multiplying by 1/2. That's what it comes down to. So on the left, or on the left side of the right, 1/2 times 2 cancels, so we get x less than negative 17 over 4. Okay, to graph this out, make our 2 tick marks. All right, we have to put the smaller one on the left. So, which one is smaller? Negative 7 or negative 17? So, if you think about it, negative 17 is going to go on the left. And it's because, or the negative 17 over 4, right? That's 17 divided by 4. It's 4 something, right? Negative 4 point something. There's approximately negative 4 point something. And then negative 7/2, or 7 quarters, right? 7 divided by 4, is approximately 2 something. Negative 2 something. So negative 7/4 is bigger in a sense because it's closer to 0. The larger the negative number, the smaller it's going to get to the left. Okay. Hopefully you can follow that logic. All right. The circles are going to be open because they're strictly less than, strictly greater than. So x is greater than negative 7/4. So greater than negative 7/4 is to the right. X is less than negative 17 over 4, and that is to the left because it's less than. Okay, again, negative infinity is to the left. I write it out of habit, and infinity is to the right. So now it should be clear on how the interval should look. Right, these two numerical values together, these two numerical values together. Everything's with parentheses, right? Infinities get parentheses, and both of these values are going to get parentheses because it's open circles. It's open circles. So negative infinity, negative 17 over 4, parentheses, union, because we know it's going to be 2 pieces, parentheses, negative 7/4, infinity, parentheses. There it is. All right, last problem. Let's see what this is about. Oh, this is a nice one. So hopefully you can see it right away what's about to happen. So 2 times absolute value 3x minus 4 less than or equal to negative 8. I want to isolate, right? Stick to the script. Stick to the script even when you think you know what is happening. Left side with cancels, so we get absolute value of 3x minus 4 is less than or equal negative 4. Right, 8 divided by 2. Okay. Hopefully right now you see what's happening because it's so easy to just keep pushing, right, and be like, all right, I'm going to split this into 2, make one positive, one negative, and keep going. But notice, this is negative. It's negative right now before we do anything. So when it's negative, you have to consider what's happening, right? First off, absolute values are always positive, right? This thing must be positive. So it must be positive. So the absolute value represents some positive number. So if you think about it, how can a positive number be less than a negative number? Right? It can't. Right? It's just not possible. It's not possible for a positive number to be less than a negative number. It's possible to be greater than, for sure, but it definitely cannot be less than. So no solution. No solution. A positive number cannot be less than a negative number. So you have to be aware when the inequalities are equal, absolute value inequalities are equal to a negative number. You have to, it's got to be a red flag. Like it just has to be. Otherwise, you're going to miss it. You're going to keep pushing, and then it's going to come out wrong, and you're going to think that you're right. Okay, so I think that does it. Hopefully this helps somebody. Catch you guys in the next video.